All right, no prep for this one. This one, let's see, is 2005. Looks like it's a volume problem. Here we go. And we're using a calculator. Oh, okay, there was a little prep. I got my Desmos ready because I don't want you guys watching me type it in. But let's try to make this under 10. Let's see. Let f and g be the functions given by that and that. Let R be the shaded region in the first quadrant enclosed by the two graphs of f and g as shown in the figure above. So we have a point right here. We have a point right here. The first question says, find the area of R. So usually we do top function minus bottom function. So we know that the top function is going to be the f. So f of x, let's kind of, okay. And then the bottom function is going to be our g. So I'm going to put that in there like that. Don't forget your dx, and we're going to integrate. Now, in order to integrate, we're also going to need the lower and upper bound. And so in order to do that, I'm going to need a graphing calculator. So let's go over here to our graphing calculator. All right, so I put them in. I also define the functions as f and g. That way I can use the f and the g labels later. Now, if you're using Desmos, you just have to tap the points of intersection. And so it looks like the point of intersection right there is 0. So I'm going to put 0 right here. And then the point of intersection for this one is 1.13569. Yes, you can round it to the third decimal, but I'm just going to write all of them. Okay, I'm going to go ahead and write the y value too. Just because I might need that later. Actually, no, because I have Desmos calculator. This is super easy. Okay, so now I just have to plug this in and see what I get. So you can type int in like if you have a keyboard, it's really fast, or you can do functions and just scroll down until you see the integral. We'll put 0 for our lower bound. Our upper bound is 1.13569. Let me double check. Yes, I typed that correctly. Next, I'm going to do an open parenthesis because you have to put parentheses around your integrand in Desmos. And then I'm going to put f, so f of x. You got to make sure you do that for the calculator. And then minus g, close the parenthesis, and then dx. Just like in your work, you can't forget that dx. So my answer is going to be 0.429. And yes, you can write all those numbers if you want, but I'm just going to round to the nearest third decimo. Okay, and then after I finish, we'll go check my answers and see if I'm right. Okay, next one says, find the volume of the solid generated when R is revolved around the x-axis. And so here's our x-axis right here. It is revolved around this x-axis. Now, when this outer function, which we know is, what is that? That's f. Yeah, this is f. When that one is revolved, that's going to be the bigger solid. When the other function is revolved, that's going to make a smaller solid. That will be your void. Here, I'll go ahead and I'll draw the circle for this one. This is my radius. And then this is what my circle would kind of look like. Yep, that's the void. So those are all the disks you got to find the volumes of and then subtract them. Okay, so here we go. So let's start out with the blue one again. How would we find this radius of the blue one? Wouldn't it just be, because we're just revolving around the x-axis, which is y equals 0, we would just do f. F is the radius of this function. We don't have to do any subtraction. I say that because in the formula, we have outer function minus the axis of revolution. Well, the axis of revolution is 0, so that's not necessary. You don't have to do it. So let me write that out. We have the integral from 0 to 1.13569 of f of x squared. That's the radius. And don't forget your pi. So that one right there is the volume of the outer function. It's the bigger volume. Then I'm supposed to subtract the other guy, the void. Same lower bound and upper bound. I'm going to show you guys how you can write this simplified later. And when I look at this one, the radius is just the g. So whatever the g is, that's all you got to do. So we got to do radius squared. And don't forget your dx. Don't forget. I'm pretty confident you don't get the points for it an integral setup if you don't have your dx, dy, dt, whatever it might be. And then you just plug this in and get your answer. Okay, but the shorter way to write this would be the scalar 0 to 1.13569, and then I'm going to go f of x squared minus g of x squared. And I'm going to go ahead and put my parentheses around that because that's what Desmos wants. Okay, so I'm going to use that second one because I don't want to keep writing stuff. So here we go. We have pi, pi, and then we have, I should have typed in int because I was right there. But no, there we go. Function 0, 1.13569. Let me double check. Yep, 1.13569. Make sure I didn't type it wrong. And then open parenthesis, and then we're going to have f of x minus g of x. Close that parenthesis. Ooh, snappity whackity. I did not square it. We got to square these foos. So I'm going to go parenthesis around that guy, parenthesis around that guy, squared. And then I have to do the same thing to the g, parenthesis around that guy, parenthesis around that guy, squared. And don't forget your dx. Cool, give me my answer. It is 4.267. All right, it doesn't ask for units or anything like that. It would be units cubed. But that's all you got to do for that one. You subtract the bigger volume by the smaller volume. Do not, whatever you do not take these squareds and just do one squared like that. You can't do that. You cannot distribute a power over addition or subtraction. Okay, last one. The region R is the base of a solid. For this solid, the cross sections perpendicular to the x-axis are semicircles with diameters extending from F to G. Diameters. Oh, okay, I see. I'm going to go ahead and bust out a picture. I did take a picture so that we can, nope, it's not that, right, allow full access. Is it there? Yeah, there it is. Okay. So our cross sections are semicircles. So what we're going to do here is I'm going to draw one semicircle. There's my diameter, and the semicircle's popping off, and then boom. There he is. Now imagine a bunch of those. A semicircle right here would be a little bit smaller. Okay. All right. So in order to find the radius here, we're going to have to find the diameter and half that sucker. Okay. So the diameter is the top function minus the bottom function. So that's going to be f minus g. And then we're going to divide that by 2. This, my stews, is going to be my radius. Okay. Now to find the area of this radius, of this semicircle, you're going to go pi, and you're going to go r squared. And since r is f minus g divided by 2, we're just going to square that guy. This is the area of each of my cross sections. And now I need to add all these cross sections together from 0 to 1 point, what was that again? 1 point, 13569. I don't know why. I was looking at the y value for that. I'm going to put the scalar, the pi, on the outside because he's not being multiplied by an x. And then I have my f minus g. I'm going to half that foo and then square it. Now I could simplify this even more. I could take out, now you don't have to. You can put this into the calculator. You're done. Okay, but for funsies, I'm going to simplify this more. This is a 1/2 right down there. If I square 1/2, it's 1/4. And so I'm going to put pi over 4 to the outside right here. Just for funsies, you do not have to do that. In fact, I wouldn't recommend it. When you guys are doing your FRQs, do not simplify things. You don't have to. Okay, that's just not. You guys make mistakes, and when you make mistakes, boo, you get the answer incorrect. All right, let me move this guy over here, and I'll plug this into my graphing calculator, and then we'll be done. Actually, I'm gonna do the big one, okay? Because I know you guys can do the smaller one. That one's kind of easier. So I have pi, and then we have int for integral 0, and then to 1.13569. And then my integrand has to have parentheses around the whole thing. And this time, we're squaring this. Oh, it's kind of almost similar to the other one. Minus, oops, I have to put of x, otherwise it won't work. Minus g of x, close the parentheses, square the foo, and then dx. It gave me my answer. 0.621. All right, that seems kind of small. So let me think here. No, that's right. Okay. Yeah. Oh, shoot. You know what I didn't do? I didn't do the half. Oh, dang. All right, so this answer is not correct, and I need to... Okay, I'm going to have to put parentheses on this whole thing so it goes up on the numerator. And divide by 2. There we go. Wow, it's even smaller. Shoot, I hope that doesn't make, like, that's an unsatisfactory answer. I'm going to double check that. First, let me do it with my simplified version. Let's see. Yeah, because I don't think I'm wrong. Of course. So 0 and then 1.13569. And then in my integrand, I'm going to go f of x minus g of x. And then I'm going to square that, and then dx. Okay, got the same thing. All right, well, let's check our answer. Okay, nope, not that one. Where'd it go? Oh, there it is. Okay, so for the first one, it was 0.429. Is that what I got? Let's see. 0.429. Yay! It is what I got. Okay, and I got a point. You get a point for the integrand and the answer. Oh, check this out. It says we get a point at the very top right here. It says we get a point for the correct boundaries, right here. Okay, but it's found in A, B, or C. All right, but we only need this guy right here. All right, so the next one says 4.266. Let's check it out. Let's see what I got. 4.267. Yep, that's right too. Looks like I would get the point for 2 points for the integrand. Shoobity doobity, and then we have 1 point for the answer. So you get 2 points for this guy. Dang. And then for the last one, C, it says 0.077, and let's see what we got here. I have 0.155. Okay, let's try to figure out what I did wrong right here. Square that. Oh, so no, that's not right. Okay, so let's think about this for a second. It says for this solid, the cross sections are perpendicular to the x-axis. Oh, you know what I didn't do? I didn't half this. I needed to half that because right now, as this sits, it's just the area of the whole circle. We need the area of a semicircle. So I got to half this guy, which would put that 2 right underneath the pi, which would make this guy an 8. So if I go over here and fix that, dang, I can't believe I made that mistake. I made a mistake in front of you guys. I put an 8 right there. Yeah, it looks like I get the right answer. Okay, so let's put a divided by 2 right there. Oh, that's the wrong one. I'm supposed to put it right there. Divided by 2. Okay, so 0.077, which is the correct answer. Dang, what a doofus. So that's not it. I would have got that one. 0.077. It looks like I would have lost this last point right here. Shoot. I got the integrands all correct. Oh, no. Well, I technically did because this is a scalar, so I don't think that would count in the integrand. And so I would get this one correct, or maybe they would just give me one of those points. I don't know. I could have lost 1 or 2 points right there. But that's how you do it.